Section 5.8, the quadratic formula. In this section, we're going to learn how we can use the quadratic formula to actually solve any quadratic equation, as well as how the discriminant can tell us what type of solutions my equation is going to have and how many before I actually calculate using my quadratic formula. So let's get started by introducing the quadratic formula itself. The quadratic formula is derived by solving the equation ax squared plus bx plus c equals 0 in its generic form, and it translates into this formula here. And in this formula, okay, right here, this is called the quadratic formula, we're actually going to see the opposite of b plus or minus, remember because we're going to have two solutions, b squared minus 4 times a times c, and then this entire quantity will be divided by 2a. And the numbers that I'm going to substitute into this formula come from my quadratic equation, the a, the b, and the c that I get from my quadratic equation. So when I use the quadratic formula, there's two things that are going to be important for me to do. Number one, make sure that it's equal to 0. And number two, I need to identify what the values of a, b, and c are. And you'll remember that a, b, and c are coefficients, so they should be numbers. You should never be substituting variables, in our case, into this formula for anything. All these things should end up being numbers, and we should be able to calculate a value for x, actually two values for x, when we are finished with this formula. Okay, so let's look at how this is going to work. Now, just to help us out a little bit, I'm going to rewrite the quadratic formula up at the top of my page here. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2a. Okay, so let's get started. If I look at my example a here, the first thing I said we need to do is make sure that it's equal to 0 before I start deciding a, b, and c. Okay, and this one is. So the next step would be to just kind of get in my mind what a and what b and what c are going to equal. Now, in my case, a is a positive 3, b is a negative 5, and c is a negative 2. So then from there, we're simply going to take our formula and substitute every value into the appropriate place. Okay, so in my formula, x is what I'm solving for. I start with the opposite of b. So since my b is a negative 5, I'm going to start with a positive 5. Plus or minus the square root of b squared, so that's a negative 5 squared, minus 4 times 3, that's a, and times c, which is a negative 2. And then this entire expression is going to get divided by 2 times a, so in my case 3. Alright, now, when I do the quadratic formula, the next thing that I focus on is I focus on this under here. And I want to go ahead and calculate this all together. So I'm going to go ahead and I'm going to do my 5 squared, okay, my negative 5 squared actually, and I'm going to get 25 out of that, and then I'm actually going to go ahead and do 4 times 3 times negative 2. Okay, so what happens here is this is 25 minus, this ends up being a negative 24. So I actually end up with 25 plus 24, and I will end up with this. So what I usually do is I go ahead and calculate that, and then I write down this would be a total of 49. Okay, so I got the 49 by calculating all of this underneath my radical sign here. And then on the bottom, okay, I go ahead and I calculate my 2 times 3, and I'm going to put that down here is 6. So I end up with this, 5 plus or minus the square root of 49 over 6. Now I take care of my 49. 49 happens to be a perfect square, so I can go ahead and make that 7 over 6. Now my two answers, right, I've got plus and minus in here, so that means I have to do this calculation twice. I have to do it once with plus and once with minus. So I'll end up with my two solutions being this. 5 plus 7, which is 12, and 12 divided by 6, which is 2. And then my second solution, which is going to be 5 minus 7, which is a negative 2 over 6, and a negative 2 over 6 gives me a negative 1/3. So my solutions here would be 2 and negative 1/3. Okay, let's slide over here and do this next one. This time I start with 2x squared minus x equals 3. And again, first this needs to be equal to 0 before I can pick out my a, b, and c. So to do that, I would have to start with 2x squared minus x, and I'm actually going to subtract 3 from both sides. So I end up with 2x squared minus x minus 3 equals 0. Okay, now I'm ready for my a, b, c. A is a positive 2, B is a negative 1, and C happens to be a negative 3. Okay, let's start putting things into our formula. Okay, so I'm going to get x equals the opposite of b, so that'll start with a 1, plus or minus the square root of b squared, minus 4 times a, or 2, and c, which is negative 3. And then all of this gets divided by 2 times a. Okay, so let's do our calculator. I'm going to calculate the number that belongs underneath my radical sign. So I have negative 1 squared minus 4 times 2 times negative 3. And if I calculate that out, I actually end up with 25. Okay, and then the denominator, 2 times 2 is 4. So I calculate 1 plus or minus 5, the square root of 25 is 5, over 4. So let's get our two solutions here. 1 plus 5, that's what I'm going to do next here, right? 1 plus 5 is going to give me 6. 6 over 4, I'm going to reduce that to 3 halves. The second solution that I have is 1 minus 5, which is a negative 4, divided by 4 is a negative 1. So my two solutions to this would be 3 halves and negative 1. Now, these two problems, they worked out nice. I got two real number answers, and they look fairly easy. Now, you will come across some that you will have some radicals in your answer, because not all perfect squares will, or not all square roots will come out to be perfect squares. But I'm going to save those to take a look at during class time. I just kind of want you to get the idea of how this works and what you need to calculate, so that in class we can focus on what do you do with those square roots that don't actually aren't actually perfect squares. Okay? All right, so let's go on to the next one. Okay, and the next thing that we want to talk about is the discriminant. Now, the discriminant is a very specific part of the quadratic formula. And if you look here, I have this in red, right? The discriminant is actually this little part here that goes under the square root. This is the part that's going to tell me what kind and how many solutions I'm going to have. Now, we know that most quadratic equations, you'll usually get 2 solutions. But sometimes you will get only 1 solution to that equation, and that has to do with whether or not it would be at maybe the vertex where there's no corresponding point. Okay, so we're going to calculate the discriminant, which is simply what we kind of were already doing before. We're going to calculate specifically the number that belongs under the square root sign, but we're not going to calculate anything else, right? Because all I want to know at this point is the discriminant. Okay, so let's look at how this works. If your discriminant comes out to be a positive number, this tells me that I'm going to have 2 real number solutions. Now, that could be 2 solutions like x equals 4 and x equals 2, or it could be 2 solutions that still have square roots in them, as long as they're real numbers. If you get a 0 for your discriminant, you're going to have only 1 real solution. Okay, so you're going to have just 1 point that fits that particular spot. And if you get a negative number, right, that number is going under a square root sign, so when I put a negative number underneath a square root sign, I'm going to get 2 imaginary solutions. Okay, so my solutions are going to be imaginary or complex, if you want to call it that. You're going to have those solutions because anytime I square root of negative, that's where my imaginary numbers come in. Okay, so let's look at these 3 over here. Now we're finding only the discriminant. We're not finding everything else. I'm not solving this clear down to what x should be. I just want the discriminant. Okay, so let's look at the first one. It already is equal to 0, so all I need to do is calculate for the discriminant, right, b squared minus 4ac. Okay, that's all I'm calculating. I'm not going to square root it. I'm not going to finish the quadratic formula for this. All I want to do is calculate the discriminant, and then I want to tell how many solutions and what kind they'll be. Okay, so let's do that. B squared. So on this case, my B is 6. So I'm going to start with 6 squared minus 4. A would be 1, and C would be 8. So I'm going to calculate this out, and I'm going to end up with 4. So when I look at the number 4, my discriminant is 4. Okay, that's not my solution, that's just my discriminant. What does 4 tell me about what kind of solutions I have? Well, if you look over here, 4 would fall under the category of being a positive number. So that tells me I'm going to have 2 real solutions. So I would write down 2 real solutions. Okay, I have a discriminant of 4, which tells me that I'm actually going to have 2 real solutions. All right, let's try the next one. Again, my b value is 6, so I start with 6 squared minus 4. A is 1, and C is 9. So let's calculate that. And I end up with 0. Okay, so with a discriminant of 0, I'm actually going to then say that if I have a discriminant of 0, I have only 1 real solution. So I'm just going to say 1 real. Okay, so for my last example, let's do that one. Discriminant, start with b squared, so that's negative 5 squared minus 4. A is 4 and C is 7. So I end up with a negative 87. That's my discriminant. So if my discriminant is negative 87, I'm going to say 2 imaginary. Solutions, right? Negative numbers under the square root are going to give me imaginary solutions. Okay, so if you can manage those two things by class time, you should be in good shape. And like I said, we'll spend some class time looking at using the quadratic formula and what happens when you don't get a perfect square for your discriminant.